Hi everyone, and thank you for coming to my talk. I can't believe it's not real data, an introduction to synthetic data. My name is Mason Egger, and I'm the lead developer advocate at Gretel AI. If you have any questions for me regarding this presentation or anything else, feel free to follow me on Twitter and go ahead and tweet at me or send me a DM with any of your questions, and I'll be happy to answer them. So let's go ahead and get into the presentation. So first, go ahead, I want you to imagine that you're a developer at work working on a web application. We're going to call it Django because it's my favorite Python framework. At work, and you're trying to create something that manages students in a classroom. Okay, so you're adding students, removing students from classes, grade management, all of that stuff. And oh no, it's time to test that thing that we all should be doing. However, you can't access the production database for security reasons. Student data, known as FERPA data, is protected by law, so you're unable to access any of this data for your testing uses. So you end up having a test database that you created using some fixtures, but it's only got a handful of records. It's not really robust, and it doesn't really represent the student population. And oh no, an edge case slips through, and there was something that wasn't represented in the test DB, and now you have a bug. Or let's go ahead and go on the flip side. Say that you're a data scientist and you're trying to build a model. For this example, let's pretend that you work in a hospital and you're trying to predict a rare disease based on patient data. So you start looking for relevant data sets, but you soon find out that you just don't have enough data. There's not enough data on this that you have access to. So you end up having to train your model on this limited data set to try to predict this rare disease. And the model is not very successful. It doesn't really predict real well. It doesn't really work because this data set size that you had wasn't large enough. But wait, you're suddenly given inspiration and you go and ask some colleagues at another hospital if they have any similar data. And it turns out they do, and you'd be able to use it. Oh, but the door slams in your face again because you can't get access to this data due to its personally identifiable information within it. So those are two scenarios that probably happen on a regular basis and a lot of people end up having problems with. So let's talk about some common data challenges that the developers will deal with. The ability to access usable testing data is very difficult for developers to be able to do. 35% of all time being done in the data science and the machine learning phases are being spent in the data gathering stage. Most of this data is inaccessible due to PII, so they can't get access to it. Another common data challenge are the limited data sets, as we saw in our other example. Lack of quality data can affect the training model results, and it can be prohibitively expensive or even actually impossible to collect more data to make it where you can train these models better. And then we have biased data sets. Data can be skewed towards a representation of subjects in general, or that is not a complete set, and it can be bad. And biased data never leads to examples or results that we expect it to. So these are some very common data challenges. How do we solve this problem? And the answer to this is actually the solution is synthetic data. Synthetic data is artificially annotated information that is generated by computer algorithms or simulations commonly used as an alternative to real-world data. In not so technical speak, you can create data based on other data that is representative of the other data. So I know the first question that people ask, and the first question that I asked when I first heard about this was, wait, isn't that just fake data? And it's not. There is a difference between synthetic and fake data. Synthetic data is different from what we would call fake or mock data. You may be thinking of something like Faker. It's a very popular Python package that many of us have probably used. Fake or mock data may not be representative of the data set that you're trying to, replicate or expand upon. It's based out of pure randomness. It just randomly creates data. A common complaint that we hear is that fake data is often too clean. There's just too much. It's too nice. Data doesn't look that nice in the wild. Data is messy. Anyone who's ever worked with data knows that data is really ugly when it comes in. Synthetic data is generated from existing data. It will look and behave like the initial data set. So instead of being random, it looks at the other data set and goes, oh, okay, and gives me something that is statistically equivalent and similar. Synthetic data can be nearly as representative, if not just as representative, of the initial data set. So let's go ahead and talk about the benefits of synthetic data. And today we're going to talk about what I call the top 3 benefits. Making private data accessible and safely shareable, able to safely share with your colleagues, generating more samples with limited data sets, and reducing bias in machine learning data sets. So, number one, make private data accessible and shareable. Data often contains personally identifiable information, or PII, making it very risky, or in most countries, very illegal to even touch or deal with. Look into GDPR, it's no joke. And in the reality of the things is developers don't want access to this kind of data. They don't want to be responsible for this. I would never want to be responsible for someone's personal information in my data set. I don't really care about their personal information. I want to test the code or train the model. Like, where you live isn't irrelevant to that. So we don't want that. Developers do not want that hot potato. So generating synthetic data allows you to have a similar data set while removing the PII. All of the PII becomes fake or generative PII, so you don't have to worry about leaking anything. This allows us not only to share our data within the company, but also potentially externally as well, which is great for research and all different types of applications. So the second thing that we can do with our data, or that synthetic data allows us to do, is allows us to augment small data sets. Not having enough data is a serious bottleneck, both for testing, but especially for the data science and the machine learning applications. Data is often our most valuable asset, and collecting data is very expensive and very hard. It takes a lot of time, as we saw from that previous slide, and a lot of people just don't have the time or the resources to gather that data. Startups often don't have the resources for this. So synthetic data allows us to generate an unlimited amount of data based on this relatively small data set. This is especially prevalent in the public sector, where poor data practices, such as storing data in unreasonable formats or unreadable formats — you would not believe how much stuff exists just in a PDF, causes for an abundance of inaccessible data. So being able to generate or augment this data set, so that way it's representative of the initial set, but now it's larger so we can get that representation into our model, is very important and very awesome power of synthetic data. And finally, it can reduce bias in data sets. And this is a big problem, as we've all seen. We've probably all read news articles of like this machine learning model or this AI did something awful because it had a biased data set. We see these all the time. Synthetic data can allow you to reduce bias of your data set. Data, as we know, bias leads to inaccurate models, unfair results, could even cause some harm, so we want to get rid of it. If you can identify the bias in your data set, you can use synthetic data to balance your data set. So a really cool case study that the company that I work for, Gretel, has done about reducing AI bias in synthetic data in heart disease prediction models was exactly that. The data set was very heavily skewed male to female, 60% male, 32% female data on a 2-to-1 ratio. They were able to use synthetic data to augment the female portion of it, to expand upon it, to make it where it was more even, a more 50-50 balance in the heart disease data. And the increase in accuracy went from 88.5% to 96.7% able to predict heart disease in patients now. So the bias created an inaccurate model. 88%, not the greatest, but 96, way better. So we were able to create and improve upon that by just augmenting the female data set, so that way we have more data points when training. So now 6.17% more females with heart disease could now accurately be diagnosed by that model. So you may be going, whoa, that's really cool, but like, is it accurate? Like, how is the synthetic data accurate? Well, unlike fake data, synthetic data is nearly as accurate as the real data. And in some use cases, which we have a link to in the slides, the accuracy is improved. Augmenting a training set with synthetic data had a mean machine learning accuracy less than 1% of the real world equivalents. So yes, synthetic data is more accurate, is just as accurate, probably a little bit less, but in some cases a little bit more than data. It's definitely going to be more accurate than fake or mock data, which is, again, is just asking dev random to produce data for you. That will not in any way be representative of the population that you are trying to gather within your data set. So let's talk about synthetic data in action. Oh, I've just heard about this. Is it out there? Well, yes, it's a relatively new topic. A lot of people don't know a lot about it, but it is out there, and there's a lot of people using it right now. It's being used in automotive and robotics for helping test safety and crash prevention technologies, creating simulated environments. It's used a lot in self-driving car software to generate more issues that are happening on the road for your self-driving car. Issues that happen very rarely, especially when you think of like Internet of Things or time sensor data. If you're doing like a sensor, and maybe that sensor sends a signal when it's about to fail, but that only happens like once every 5 to 10 years. How do you have enough data to test on that? Well, with synthetic data, you can expand upon it, create more of those cases, so that way you can test your code and make sure that you can get to it. Financial services are creating time series data to enable data sharing that doesn't compromise customer privacy. The cybersecurity industry is using synthetic data to train models to detect fraud and cyber attacks. Healthcare is currently using synthetic data to create genomics data, so that way we can help with medical breakthroughs and encourage better care. I never thought about genomics data as PII, but if you think about it, it's literally the blueprint of a person. So like that kind of blew my mind the first time I heard about it. Manufacturing using synthetic data can help simulate complex supply chain operations, which we are constantly hearing about the supply chain these days. So it can help predict failures and more. There is so much more that this is just the little bit that I chose to highlight today. So how do you get started using synthetic data? Well, there's many resources available. There's this wonderful thing, opensourceagenda.com, which has like a list of all these awesome synthetic data issues. But I work for Gretel, so I'm here to tell you a little bit about Gretel's open source project. Gretel makes it easy. All of our models are open source. There's multiple models right now. There are no code options. So if you don't have to be like an expert in synthetic data to generate synthetic data. This is like synthetic data as a service. You can run it in the cloud or you can run it on-prem. So first, let's talk about the open source model. So we have open source code. All of our models are in open source repositories on GitHub. They're open source. There are multiple models. There's a LSTM. I'm not going to remember what that acronym stands for at the time of recording this. There's GPT-3. We have another model coming soon that's going to really improve the accuracy of our time series data. And there's going to be constantly more and more models coming out as we build out. You can train these synthetic models yourself. So like you can train the base model yourself. You're gonna need a GPU. This is training machine learning. So if you don't have one on your machine that you can use, you can easily try one out with, say, like a cloud provider. But just be wary that can get very expensive really quickly. So if you want to check it out, you can check out github.com/GretelAI/Gretel-synthetics. And from that page, you can also find our documentation. Now, if you don't want to train your own model and you just want to try it out right now, you can literally sign up for an account today and try it out right now. Or if you don't have a GPU, I don't know how old my GPU is in my PC, but I would not want to try to train a data science model on it. There is a free tier, and there's many ways of running. There is a dashboard, which offers a no-code solution. There's a CLI. There's a Python SDK, which tends to be what I use the most. I run it in my notebooks. You just say, hey, generate me some synthetic data, and boom, it generates synthetic data. There's a REST API, all sorts of options. So if you don't have the time to do the open source route and train it yourself, feel free to try out the Gretel Cloud, and you'll be able to generate synthetic data within 10 to 15 minutes easily. So there are a couple of additional resources. You can look at the docs. You can look at these things called Gretel blueprints. So if you've already looked into this and you're like, oh, I really like that, but I don't want to start from scratch. Hey, most of the common use cases we have already documented with full notebooks that you can try out today. You want to do data from a relational database? We've got a notebook there showing you exactly how to do it. You can also do Gretel.ai Fun with Synthetic Data. This is a repository that I am currently working on. The first one generates cocktail recipes from a long list of cocktail recipes and then uses GPT to generate new cocktail recipes. Some of them look really interesting, some of them not so much. That's the fun of GPT. And now for the fun part that everyone's here for. Not always, because not everyone always does this, but we have some free swag for you. I used to love coming to PyOhio in person. It was one of my favorite conferences. It still is one of my favorite conferences. I love this format, but I love getting swag. So if you've seen this little I can't believe it's not data, it's over there somewhere, logo that's just been floating around my talk, we have this as a sticker. You can either scan the QR code or you can go to grtl.ai, that's our bit.ly, /PyOhio 2022 and fill out your information, and we will mail you this sticker and maybe some more. We'll see what we have printed. So go ahead and fill that out. That's all I have for this time. Follow me on Twitter if you have any questions. If you want to keep up with what's going on in the synthetic data space, follow Gretel AI on Twitter. You'll see me popping around there too. You can go ahead and get started with Gretel at gretel.ai. And if you want to go over these slides yourself, they're all on my website at mason.dev. It's probably going to be one of the top links on there, but just look for I can't believe it's not real data. They'll be right there. Thank you so much. I love speaking at PyOhio, and I hope you enjoy the rest of your conference. Have a good day.